Okay, so we start. What we did last time was fast text. Any questions in there? So you give a center word and what you learn is a context word but bag of words, so subwords, right. So this is your center word, this is your target word. All right, so we were done with this. What is the date today? 7. So now that we know a little bit about how do we represent words. So how do we represent words finally? You can use embeddings from Word2Vec or from GloVe or from fast text, whatever makes you happy you can use that. Okay. So we now know how to represent words. Now today what we are going to do is we will start. So the name of the course is large language models. So we will first start with language models. Okay. So today we are going to talk about language modeling. Okay. I prepared a lecture on RNNs, but then at the last minute I decided we will do language modeling first and then talk about RNNs. Okay. So what is the problem of language modeling? So if I ask you this question, so my today's sources are CS224N. So CS224N Stanford and lecture notes or basically slides so lecture 5, so I think that should be it, language models and RNNs. So lecture 5 on language models and RNNs. 23, not 24. So winter 23. Okay. Okay. So this is winter 2023. So the question that we are asking here is, if I ask you what can come at the blank space? So I have something new here. So what did you say? So let us fix ourselves to just one word, although bank account can be here. So yes, so there are so many things. Books, laptops, what else? And right, but lunchbox, I don't know. So this might be, these might be two words. Anyway, what else? Somebody also said startup. I don't know, but anyway, so there are so many candidates. But if you talk about vocabulary size, these candidates are very few compared to vocabulary size. So the question here is, how are you going to generate this last word? So the problem of language modeling. So language modeling is this problem of predicting what comes next. So language modeling is basically what comes next. And this is what we say ChatGPT, GPT-4 all are doing. They are basically predicting text token by token. Okay. So the students opened there, and this particular place has a lot of possibilities. Now which one exactly, so which one will come? How do we decide which one will come? How do we decide? Previous? So right now we are not talking about conversation kind of things. Right now what we are talking about is you have a huge corpus at your disposal. That is what we have. So now what? Sorry? Most frequently used, like? Right. So that makes the probability of startup highest. Okay. Okay. So formally what we can say here is so given a sequence of words, given a sequence of words x1 right? This is the question that we are asking. Given a sequence of words x1, x2, x all the way until xt, compute the probability of xt plus 1, of course given all these words. Now where this thing can be any word in V. So we are still at word level right now, we have not gone to subword or token levels yet. Given this sentence, the students opened there, we are supposed to fill this question mark, and we saw there are many candidates like books, laptops, exams, lunchbox, startup and so on. Right. So, and we use language models every day. In what? So when we are typing in WhatsApp, right, it gives us three suggestions for the next word, right? That is nothing but language modeling. If we are searching something on Google, it already, so you write something and then gives you a list of n searches, auto completing a lot of things. That is nothing but language modeling. So we have been using this for quite some time now. ChatGPT is nothing new. Now, so language modeling is also, so you can also think of this language modeling as a problem to predict the probability of a given text. So basically, so for example, if you have some text x1 to xt, then the probability of this text is, so probability of x1, x2 till xt all the way until probability of right. So, which is same as right. So, what is the problem we are solving? Language modeling. Our goal is to predict what is the next word given a sequence of words. So, possible completions here could be book, laptop, exams, lunchbox, whatever. Okay. So, what we are saying is, given a sequence of words x1 to xt, compute probability of the next word, of course given x1 to xt. And so, what is this thing? This part below this line? This is simply we are just trying to assign a probability to a piece of text, which is the probability of first word multiplied with the probability of second word given first word, then multiplied with the probability of third word given that first and second word, and so on. So, probability of tth word given all these words that occur before tth position. So, this is nothing but multiplication of all these probabilities. So, these two problems in literature are considered same. So, whether you try to predict the next word or whether you are trying to assign the probability to a piece of text, both these problems are called language modeling. Okay. Now, so we are supposed to answer what comes here. How do we go about solving this problem? So, let us say if we start using n-gram language models, see what we want to do here is the students open their fill in the blanks here. Some candidate must come. Okay. Question is, how do we figure out which word comes? That is the question that we are trying to answer. So, now we assume we know something like word embeddings. So, all these things are given in their word embeddings. So, we have the basically mod V cross 300 matrix of word embeddings. For every word in vocabulary, you have a, let us say, 300 dimensional word embeddings. So, we first start with something called, what will be the easiest thing to do? I mean, the thing that will come to us first. The word with the highest probability, but how do you compute that probability? Most frequently occurring, but how do you compute that? So, you are right, but how do we compute that? So, we talk about n-gram language model. Right. So, question is, how do we learn a language model? And what we are saying is learn n-gram language model. What does that mean? So, what is n-gram? What is unigram? Just the vocabulary, one word. What is a bigram? Two words. In continuation, two words, right? Trigram, 4 gram and 5 gram, you can go all the way until n gram. Now, if I give you just 1 gram, is it possible to predict the next word? Not really. What about if we talk about, let's say, 2 gram? So, what will be, let me rewrite, what was the thing here? And we are supposed to predict this one. How do we compute? So, I have huge corpus, okay. What do we do in that corpus? So, no deep learning, nothing fancy right now, simple things. No. Yes. See, I have huge corpus. What I see, since I am talking about 2 grams, what I do is, which bigrams am I interested in this case? If I am talking about bigrams, I can remove which part? This part is gone. I just care about what occurs after there, okay. So, in my whole corpus, what do I see? In my whole corpus, what do I compute? I compute the occurrences of there and what comes after that. There won't be just one single word, so there will be a lot of words. So, maybe, so let's say in my corpus we have their books, their laptops, what else? Their lunch box, and so on. So, there is a whole list, okay. Now, let us say their book occurs, so I am taking random numbers now, okay. So, let us say their book occurs 4000 times and their laptops occur 2000 times, lunch boxes 1000 and so on. So, you have this whole list, okay. What do I do now? So, what is the probability what is the probability of books given there? So, I basically take sum over this, okay. So, let us say sum is capital N, then what is the probability of books coming after there? 4000 by N. So, this is 4000 by N, and similarly the probability of laptops. So, let us simplify our life, let us keep N equal to 10,000. So, N equal to 10,000, so this becomes 10,000 which is 0.4. Laptops, what is the probability? 0.2. Probability of lunch boxes is what? 0.1 and so on. What do I do next? Right? So, done? So, we will complete this with books. What is wrong with this? So, right. So, what is the problem? Okay, we'll come to that. So 2 gram is certainly short, but I don't want to write 4 grams. So I didn't want to write that much. So no, but what is the problem with maximum probability approach? Maximum probability does not work because it will always give you the highest probability one. Is that the right thing to do? No. So then how should we take it? Instead of saying maximum probability, we should choose word from this probability distribution. So what does it mean? That when you will see there, 4 times you will complete it with books, 2 times you will complete it with laptops, 1 times you will complete it with lunch box and so on. So this gives kind of a fair chance to every word. Okay. So we have broken that thing that, so in this case hypothetically this is 0.4, but in general this could be, let's say for a word it is 0.04 and for all other words it is lesser than 0.04, but this of course sum to 1. So this 0.04 is, so when we take this probability maximum, what are we essentially doing? We are kind of assigning probability 1 to the word with highest probability, right, which is wrong. So what you are doing is you basically talk about this distribution, choose a word from this probability distribution. Make sense? Okay. Okay, so now what was the problem with everything that I did? This is probably too small a context. So if you talk about, instead of bigrams now trigrams, so you will have opened there. So just by including one more word, you have become more specific, right? Just inclusion of one word. So now instead of their book, so what will you look for in your corpus now? You won't talk about just there. You look for this phrase, opened there. Okay. So that same thing, I am not doing it again, but you may write it, opened their books, opened their shop. So that's a good thing. Open their laptops, open their lunch box, and so on, so many things. Okay. Do you think trigram is sufficient? So then you want to go to 4 grams, let's say. So in that case, what will happen? Students, right? So there's something. How can we complete this there that doesn't fit here? So let's say, what can come after there? Forget this sentence. Their age, right? So their age. I will see a lot of times in my corpus their age, okay, which is not the right word. But the moment I say opened there, age cannot be there now, right? So it becomes more specific. Now this could have been the shopkeepers opened their shops. But the moment you say students, you are bringing more context in. Now it cannot be shopkeepers opening their shops. So students opened. So the more you increase this n, so we started with n equal to 2 bigrams, then n equal to 3, then n equal to 4. You keep on increasing n, right? Your context window is increasing and you are able to guess the right word. What are the downsides? In computer science, you don't gain anything without giving up on something else. So, what is problem here? Simple problem, you don't have to think a lot. I am not talking about computation right now. There is a common word. So, this kind of occurrences will be a lot, but they will be out of context. Okay. So, to remain in the context, we said increase n. Now, these kind of phrases will be too many, but certainly opened there will reduce drastically, maybe by a few orders of magnitude, right. This one will reduce further drastically. So, what does it mean? These things will keep on reducing significantly. So, let us say earlier you had 10,000 such occurrences. When you started talking about just opened there, now let us say you have just 200 occurrences. When you talk about students opened there, let us say you have just 20 occurrences. So, now when you are assigning probabilities, right. So, with increasing context, you are decreasing the training data here. No, but at some point, so for example, the students opened there. So, this thing let us say occurs only once. So, let us say in my whole corpus, the students opened their books is the only sentence. What will I end up doing? The students opened their books, assigning probability books equal to 1. This is still okay. Let us say in my corpus, if the students opened there, this phrase is not there at all, but it comes in test time. In that case, I have assigned probability 0 to everything. Okay, what should I choose now? So, I should be able to assign some non-zero probability and I should not be able to assign super high probabilities like 1. So, I do not want probability of 1 to anything because that basically fixes that word. I do not want to assign 0 because just because some phrase is not there in my corpus does not mean it is invalid. Okay. So, what do we do?
Probability allow word embedding.
No, in the end you need a probability. In the end you need a probability because you want. No, see, word embeddings solve a different problem. What is that? Word embeddings solve this problem that you were not even able to give inputs like the students opened there to system before. Now, after learning word embeddings, you have a way that instead of entering the, you will enter a word vector of the. Instead of students, you will enter a word vector of students. So, that thing is taken care of. Okay. So, word embeddings solve this problem of how do you provide words as inputs, that is it. It is not solving your problem, this problem right now. So, what they do is, no. See, those were the algorithms. So, we have switched our thing now. In whatever we have done until now, basically we did for we wanted to learn how to represent words. Okay. So now we can start talking about words, but those techniques, they don't directly help us with language modeling. Okay. Yes.
We can train a data on real time, like what we do on WhatsApp chat.
Right. So this is what you are supposed to do. So you are supposed to train this kind of a thing. Given this, what is the probability of next word? And that's what we are doing. So this is what we are doing. We are training. The thing is, we are just training it statistically. So there is no neural network until now. Okay, that's the only thing. So we have seen the good sides of this model are, if your corpus is huge, most likely. So let's say if you can answer, if you can predict good words, let's say using 3 gram or 4 gram, that is still okay. But if you need more context, then this also has a downside. So we quickly want to get rid of this kind of solution. But I mean, talking about this gives us a very good understanding of what is the problem of language modeling. So everybody understands what is the problem of language modeling. So that was the goal. Now, right, so I don't want to do as much on n-gram language models as they are doing. My goal was just to talk about, and there can be problems with this. We have talked about you can assign probability 0 in case the phrase does not occur and so on. Okay. So we are done with n-gram language modeling. Now what we do is, so initially I had not thought of doing RNNs in this course, but I think it does not harm if we have 2-3 lectures on that. What is the full form of RNN? So recurrent neural networks. So what are RNNs? Anybody seen this structure before? So what we are saying right now, let me just wrap up again. The students opened their question mark. This could be solved using n-grams approach, but that problem has that solution has its own limitations. So now we are going to neural networks. Okay. And those who want to go into details of this, what more problems occur, you can go to CS 224N winter 2023 lecture 5. Okay. Right, but we have mostly talked about we have mostly talked about things here. So what was the language modeling task? What was it? Anybody remembers? Given input sequence x1, x2, xt, right? So this is the problem of language modeling for us. Given input sequence x1, x2, x3, so it is not happening that x2 can come after x1. We are talking about a sequence in a language, so x1, then x2, then x3, all the way until xt. The probability, so we want to compute the probability of the next word, which is xt plus 1 given all these words. How do we do it using neural networks? Hmm? Right, so say that again. But to whom? You have to first give me the architecture. What should I, so what should be my neural network? How should it look like? So let me try to do what we were doing until now. So how does a neural network look like? I mean, of course you can have more hidden layers, but I am drawing just one. Okay. So this is my input layer. This is my hidden layer and this is my, how many neurons will be there in, no, you have to give me the number of, you have to give me this architecture. Mod V, everybody agrees? Then tell me, how does it work? Yes. What do I do with this mod V? This is the architecture of word2vec, glove, fast text, right? We are done with this. So can you help me improve now? What is my task? See, you must be very clear with the task. What is task? I want to compute probability of next word. Now next word will be drawn from, no, will be drawn from what is my probability distribution. This is a distribution over my vocabulary. Okay. So I will be assigning a probability to all words in my vocabulary. Okay. So last should have mod V, because my output could be any of the words. Okay. So let us keep it mod V. What else? Yes. Right. So how do I input? That is the main question. What is my input? So I just want to input what comes after. I mean, so my actual sentence is now the students opened there. These 4 words are input. How do I input? Like? Okay. I input the, so give me the size of input layer. Dekho, everybody agrees hidden layer is something we don't really care too much about, because we can keep whatever. The problem is, how do we fix the output and input layer? So what is it that you are going to input? You are going to input words, but now we know that we don't input words, we rather input word embeddings. So what should be the size of word embedding corresponding to the, okay. So let's say I enter word embedding corresponding to, so how do we represent that? Embedding, हाँ. So you input the, what does it mean? The input size, the input of, I mean, the size of input layer is 300 because there is a 300 dimensional vector. I again repeat, there is nothing special with this 300. You can learn word embeddings that are of different size like 50, 100, 250, 300, 500, 1000, but we are taking 300 because even Globe did this, Word2Vec did this, yes. So what do you want to do with that?
एक बार आउटपुट आया, उसके अंदर स्टूडेंट्स आ गया, फिर ऐसे आगे चलता है।
हाँ, so let us talk about just this sentence. The students opened there. What do I do? I don't get this. Say that again. See, right now, forget fast text. Let's say you are using word embeddings from Word2Vec. So we are talking at word level. We are not talking at subword level right now. Okay. So now tell me, what should I do? Say that. So then that's not a hidden layer anymore because you are taking inputs there. So we input 4 things here. How do we do that? So that's a good idea. How do we do that? That's a very good idea. So let us do that. So this is 300, this is 300, this is 300 and another 300. So I have 1200 neurons in my first input layer. That makes sense? So now my sentence changes to, today I don't want to take a underscore. How many words are here? So today I do not want to take 8 words. How will you input these things here now? But my input size is fixed to 1200. So the way we understand neural networks today, your architecture is fixed. Your input has to change such that it fits in that fixed architecture. All right, so this makes sense again. Right, so this makes sense. Let's say in your corpus, maximum size is 47 word sentence. So you take 300 into 47 size input layer, but what does it mean? So firstly, most of your sentence will be much lesser than 47. So you will be padding zeros. Okay. What is the another downside? There is a big major downside here. That is, so let's say we have huge compute, so compute is not an issue. What is the another problem with this approach? My sentence is the students opened there. Can I say something like students the opened there? Can I say something like opened the students there? Can I say something like opened there the students? So in language, sequence matters, and we are not capturing anywhere here what is my sequence. What we are rather inputting here is a bag of words. So what do you mean by bag of words? So if I ask you this question, see, this is a sequence, this is a sequence, okay? If I ask you a bag of words forming from these 4 words, then I basically give up my information on sequence. That means I am talking about all these 4 words in a bag, not in a sequence. So if you start input here like that, right, whatever you are saying makes complete sense, but so you can input, but you are still losing the information on sequence. Because, so everybody is okay with the explanation that I have given here, or there are issues?
Sir, sequence is a problem.
So tell me now one more thing. If I input, so let me go back to my 1200 thing now, not 47 thing. My example is this now. The students opened there. Okay. The students opened there, I will input as word embedding for the, word embedding for students, word embedding for opened, word embeddings for there. And I expect something here so that the maximum probability will be assigned to, let's say, books. Let's say books. Okay. I mean, there will be a probability distribution, and according to that probability distribution, I will choose a word. So I am not going to choose the word with maximum probability. We don't do that. Now, I input the students opened there. Let's say I also input students there the opened. Am I giving the same exact input? And why do you think so?
सर उसके अंदर मतलब अपन जो अपना पहला न्यूरॉन से 300 इनपुट्स उसमें कुछ वर्ड और वर्ड एम्बेडिंग है और दूसरे वाले में कुछ और है.
But do you think I can permute things like that? It will become equivalent to original one?
Sir, input तो same है but output अलग निकलेगा.
How?
क्योंकि सर उससे previous word कुछ भी हो सकता है.
So you want to say if these 3 had, so the students opened there, right? Instead, if I change it to students opened there, this is different. How come? I mean, let's say if you are solving housing price prediction problem, okay, and you have area, you have latitude, longitude, you have number of kitchens, you have number of whatever, so you have these features. If you permute these features and give input to neural networks, it matters, you think? That is what you want to capture, but this input is not capturing that. That's what I am saying. If you input students here, there, what is left? Opened. To this neural network, it does not matter which one you are entering. Any permutation of these 4 words is the same.
पर फिर सर एरिया लैटिट्यूड लॉन्गिट्यूड, तो सर अगर अपन एरिया की जगह लैटिट्यूड लगा दें तो वो तो डिफरेंट हो जाएगा ना.
But this is taking place, I mean this is change. So let's say you did it this way in your data set. First column was area, second was latitude, third was longitude, and so on. In my data set, these columns are flipped. You think we'll get different results throughout deep learning, throughout machine learning in that case? No? See, if I get a CSV file in which I have area, latitude, longitude, 60 feet road, whatever, a few more columns, and you get the exact same CSV file, just that you have, your columns are different, but we have exactly the same data. You want a learning algorithm that depends on this, that what ordering of columns was used even though the data is same.
But sir, it will change the sense of the sentence. Like students cannot come with books or lunch box.
But that is your problem, that is not the problem of neural network. So what are we saying here? And what is it? Which statements you don't agree with?
मतलब सर उसके अंदर तो लैटिट्यूड लॉन्गिट्यूड की बात कर लो, अपन इसमें वर्ड्स और वर्ड्स ही इनपुट कर रहे हैं.
But why do you think for a neural network?
सर मेरे को
हाँ,
समझना
right, हाँ.
कि सर उसके अंदर तो दो डिफरेंट चीजें थी, एरिया अलग था, लैटिट्यूड अलग था, पर इसके अंदर वर्ड भी 300 का मतलब दो डिफरेंट वर्ड 300 की होंगे.
So
उनका वो इंटरचेंज कर देंगे तो वो मैटर नहीं करेगा. फिर वो
सर वो जिससे जितना ज़्यादा क्लोज है उसकी हम प्रोबेबिलिटी बढ़ा सकते हैं न्यूरल नेटवर्क से. जैसे सर एम्बेडिंग दा होगा, दा वो देर था,
हाँ.
वो फिल्टर बैंक से सबसे क्लोज था, सर उसकी प्रोबेबिलिटी बढ़ा सकते हैं थोड़ी सी ज़्यादा.
but am I, so you want to assign probabilities also here?
Yes sir.
How?
Their closeness.
So how do I do this now?
सर अगले जो
So I assign probability 0.5 to there, 0.25 to opened, maybe 0.15 to students and 0.1 to there. Is that what you are saying? But what are these, what is this probability distribution actually capturing? So can you say this is capturing the sequence? All this means you are giving less weightage to the, but it still does not capture sequence per se, because this word actually may depend on 4 words. So things like this famous example, the cat has eaten a lot, hence it was full. Here was depends on what? Cat. If this were cats, it won't be was, it would be were. So you have long range dependencies in the language. Language is a very sophisticated thing, right? That's why we are saying we don't want to talk about n-grams. So now having motivated enough, we know this architecture does not work. So what you do in this case is, I'll just draw the basic. So this is my neural network. So in fact I don't think so. Before I do this, let me try to. So give me just one more sentence after this. The students open their laptops. So let me. The students opened their books. Let's say I want to have one more thing later. So to study. Now if I input something like this, the students opened there. I want to give this as input and my output will be, output should be able to predict. Now I move my window next. What will be the sentence? Students opened their books. Now, so this becomes my input and my output becomes what? 2. So am I moving windows like this? If I take 4 gram before this, so that means I will always have 4 input words and I will always be predicting 1 output word. So we want to have something like this. Now if your corpus is of size 1 billion, how many examples will you have of this kind? You answer this and we go. So let's not talk about billion, let's say my corpus is of size 100 words. How will you prepare training data set? How many examples will be there? See, first word can be there, second word can be there, you can go all the way until 96, 97, 98, 99. So last word will be, first word will be 97, 98, 99, 100. So you can make 97 examples from this corpus. Okay. Now the architecture of neural network, we do it in the next class. So I think everybody agrees that this does not work, at least not directly. That's it for today.